And this is G481 homework booklet question 28. We've got a force acting up an angle of 38 degrees to the horizontal, and we're asked to calculate the components of the force. The angle we've been given is the angle to the horizontal, so that'll make the horizontal vector the x direction, so that's 20 cos 38, it comes out as 15.8 newtons. The vertical component will then just be the sine, it's the side opposite the angle, the 12.3. I think the only way I saw people getting that wrong was either getting the cos and the sine the right way around, or remember it's always cos in the direction that you've got the angle, so because that's the angle there, that must be the cos, the component will have the cos as opposed to the sine. The other thing a couple of people did was leave their calculators in radians. The angle's in degrees, so you've got to make sure your calculator's in degrees mode. If you don't know how to make that swap, just grab a quick word with probably one of your mates will know how to do it, but show the physics teachers will get you through that if you need to. So do make sure you're in radian mode. In degree mode. We've then got a metal block being held in equilibrium by two wires. And we're told that the tension in each wire is the 20 newtons. Now hopefully you recognise straight away that that force, the tension in that wire there, is exactly the force we've just been looking at. The other thing you'll notice is that we've got a symmetrical situation. We're symmetrical about here, so whatever the horizontal component is of that 20 newton force at 38 degrees is going to be balanced by that. So all I really need to be thinking about is the vertical components. So as I said, we are in equilibrium, so vertically in any direction we want, the forces are in equilibrium. Specifically in this case, the vertical direction, because that's the direction where we've got the weight. The weight's what we're interested in, and it's simply going to be the sum of the upward components. I've got a component of the upward component, the upward vertical component of that 20 newtons, and I've got the upward vertical component of that 20 newtons. Those are both 12.3, so I'm simply adding 12.3 to 12.3. I get 24.6. It is very, very important. This is a show question, so it's important that you're laying it out very, very comprehensively. We've then also got as an alternative, simply as an alternative, we could do this by vector diagram. So there's the first 20 degrees at 20 newtons at 38 degrees, there's the next 20 newtons at 38 degrees. The weight has to add up and end up back where we started in the vector diagram, because the three forces we know add up to 0. So we could do a number of things with that. I could spot that that's an isosceles triangle and split it down the middle and treat it as a pair of right angle triangles. I could work out the angles there. That's going to be 76 degrees, is it? And therefore those two, because they're the same, or indeed just because they're in a 90 degree angle with 38 degrees, they have to be, taking this slowly, 90 take 38 is 52 degrees, so those angles there have to be 52 degrees. And so I've got that side and that angle, I've got that angle, so using the sine rule I could work out that. Number of different ways of doing it. Probably the easiest there is to look at the components. So that's G481 homework booklet question 28.